Welcome to the series of e-learning modules on CPM. By the end of this session, you will be able to explain the importance of using CPM and also to explain the CPM network techniques. Now, let us start with an introduction. The critical path method is an algorithm for scheduling a set of project activities. It is an important tool for effective project management. The critical path method is a widely used technique for analyzing and managing task sequences in large projects. CPM is based on calculating how long it takes to complete essential steps of a process and analyzing how these steps interrelate. It is a visual and mathematical technique that gives managers the ability to effectively plan, schedule, and evaluate their projects. CPM associated techniques are probably most often used in large manufacturing and construction projects. They are also applied to tasks like new product development cycles, marketing campaigns, software process modeling, and research programs. Anytime a manager is trying to determine the date by which a project will be completed, he or she needs to have a basic understanding of the time required to complete each task that makes up the overall project. For small projects, managers are often able to memorize and to coordinate all of the various tasks necessary for their completion. For larger projects, however, with numerous activities occurring simultaneously, remembering and coordinating these activities can prove much more difficult. CPM and related tools allow managers to determine which particular tasks most affect the total time of the project and enable managers to better schedule each task so that deadlines are met at the least possible cost. CPM is a project modeling technique developed in the late 1950s by Morgan R. Walker of DuPont and James E. Kelly Jr. of Remington Rand. Kelly and Walker related their memories of the development of CPM in 1989. The precursors of what came to be known as critical path were developed and put into practice by DuPont when between 1940 and 1943 and contributed to the success of the Manhattan Project. Given the complexity of the process, they developed the critical path method for managing such projects. CPM is commonly used with all forms of projects including construction, aerospace and defense, software development, research projects, product development, engineering and plant maintenance among others. Any project with interdependent activities can apply this method of mathematical analysis. Although the original CPM program and approach is no longer used, the term is generally applied to any approach used to analyze a project network logic diagram. Now, next moving on to CPM basic techniques. The essential technique for using CPM is to construct a model of the project that includes the following. That is, a list of all the activities required to complete the project, typically categorized within a work breakdown structure, the time or the duration that each activity will take to completion, and the dependencies between the activities. Using these values, CPM calculates the longest path of planned activities to the end of the project and the earliest and latest that each activity can start and finish without making the project longer. This process determines which activities are critical, that is on the longest path, and which have total float, that is can be delayed without making the project longer. In project management, a critical path is the sequence of project network activities which add up to the longest overall duration. This determines the shortest time possible to complete the project. Any delay of an activity on the critical path directly impacts the planned project completion date. That is, there is no float on the critical path. A project can have several parallel near critical paths. An additional parallel path through the network with the total durations shorter than the critical path is called a subcritical or non-critical path. Although the activity on arrow diagram, that is the PERT chart, is still used in a few places, it has generally been superseded by the activity on node diagram, where each activity is shown as a box or node and the arrows represent the logical relationships going from predecessor to successor. CPM provides the following benefits. Firstly, provides a graphical view of the project, predicts the time required to complete the project, shows which activities are critical to maintaining the schedule and which are not. Now, next comes the CPM model. CPM models an events of project as a network. Activities are depicted as nodes on the network and events that signify the beginning or ending of activities are depicted as arcs or lines between the nodes. Now, next coming to CPM steps. The steps in CPM project planning are as follows. Specify the individual activities, determine the sequences of the activities, draw a network diagram, estimate the completion time for each activity, identify the critical path, that is the longest path through the network, update the CPM diagram as the project progresses. Next is specify the individual activities. From the work breakdown structure, a list of all the activities in the project can be made. This listing can be used as the basis for adding sequences and duration information in the later steps. Now, coming to determining the sequences of activities. Some activities are dependent on the completion of others. A listing of the immediate predecessors of each activity is useful for constructing the CPM network diagram. Next is to draw the network diagram. Once the activities and their sequencing have been defined, the CPM diagram can be drawn. CPM originally was developed as an activity on node, that is AON network, but some project planners prefer to specify the activities on the act. Next is estimate activity completion time. The time required to complete each activity can be estimated using past experiences or the estimates of knowledgeable persons. CPM is a deterministic model that does not take into account variation in the completion time, so only one number is used for an activity's time estimate. Next is to identify the critical path. The critical path is the longest duration path through the network. The significance of the critical path is that the activities that lie on it cannot be delayed without delaying the project. Because of its impact on the entire project, critical path analysis is the most important aspect of project planning. The critical path can be identified by determining the following 4 parameters for each activity. ES is the earliest start time in which an activity can start given its precedent activities must be completed first. EF is the earliest finish time equal to the earliest start time for the activity plus the time required to complete that activity. LF is the latest finish time at which the activity can be completed without delaying the project. LS is the latest start time is equal to the latest finish time minus the time required to complete the activity. The slack time for an activity is the time between its earliest and latest start time or between its earliest and latest finish time. The slack time for an activity can be delayed past its earliest start or earliest finish without delaying the project. The critical path is the path through the project network in which none of the activities have slack, that is, the path for which ES is equal to LS and EF is equal to LF for all activities in the path. A delay in the critical path delays the project. Similarly, to accelerate the project, it is necessary to reduce the total time required for the activities in the critical path. Now, next is update CPM diagram. As the project progresses, the actual task completion times will be known and the network diagram can be updated to include this information. A new critical path may emerge and structural changes may be made in the network if project requirement changes. Now, following are the CPM limitations. CPM was developed for complex but fairly routine projects with the minimal uncertainty in the project completion times. For less routine projects, there is more uncertainty in the completion time and this uncertainty limits the usefulness of the deterministic CPM model. The basics of the critical path method are: for CPM to be used appropriately, a project should have three attributes. First, it must consist of tasks that are independent of each other, in which managers can stop and start within the duration of the project. Second, the distinct tasks upon completion must result in the end of the project. Third, while some tasks can be performed simultaneously, others must be performed in a particular sequence. If a project meets these criteria, CPM can be used. CPM consists of three core steps, that is, planning, analyzing and scheduling, and finally controlling the project tasks. To plan a project using this method, a diagram of each of the tasks comprising a project must be devised. The diagram can be constructed by first assigning a symbol such as X, Y or Z, or identifying label to all of the tasks and listing them in the order that they are to be performed. Now, let us take a look into the basic examples and real life applications. The time estimated for each task to be completed should also be calculated or at least estimated. Now, take for example a delivery project involving the transportation of goods using 3 trucks. The project will start at place W, where all the trucks start out, and end at place X, where they all ultimately arrive. Trucks A and B go first to place Y. From there, truck A goes to place X, while truck B goes to place Z, and then eventually to place X. The third truck, that is truck C, goes directly from place W to place X. These events are represented in figure 1. This sort of visual CPM representation is sometimes called a network diagram. The estimated times needed to complete the individual segments of the trips are shown in the following illustration. Now, using the critical path method. To analyze this scenario, the manager must figure out the shortest amount of time in which it is possible to complete the project, given that all of the individual tasks are necessary and take fixed amounts of time to complete. For the above example, the answer is 5 hours, the time needed for truck A to leave place W and go to place Y and reach place X. Trucks B and C take only 4 hours and 2 hours respectively. Thus, truck A travelling from W to Y to X is seen as the critical path. Anything delaying that truck will delay the project, while all delays experienced by the other two trucks would not be significant unless they push the project beyond 5 hours. Defining the critical path can allow the manager to concentrate his or her efforts appropriately and make optimal scheduling decisions. Thus, it follows that if the project manager can reduce the time it takes for truck A to complete its path, the overall project will save time. He or she will not waste time and efforts on reducing the time spent by trucks B and C. Now, furthermore, knowing that trucks B and C have more time to complete their tasks, the manager can schedule them more conveniently. For instance, truck C is unoccupied for 3 hours and could be used for other tasks during that time. Similarly, from this analysis, the manager knows that the drivers for trucks B and C will be idle during the course of this project and their labor can be used for something else, rather than paying all 3 drivers for the project's full duration. Finally, by using CPM, the manager can control the project as the tasks are being completed. Comparing the actual performance with the planned performance will let the manager know whether or not the project is on schedule. Thus, if truck A is behind schedule, going from place W to place Y, the truck's trip from point Y to point X will have to be expedited. That is, if the project is to be completed on time. Now, following are the real life applications. The principles behind this simple example can be leveraged on much larger and more intricate projects, frequently with hundreds of steps. In practice, CPM and related project management techniques are usually implemented through the use of project management software. Software packages may be of general use, mass market titles, or specialized project software such as for the construction industry. These programs help automate the process of breaking a project into its essential task and subtask and tracking any number of variables associated with each step, including the cost. The software may also offer graphical representations of the project timeline and generate customized reports on various project aspects. Tasks in a CPM analysis are often identified with a range of potential start and finish times, as opposed to just one, to indicate best and worst case scenarios. Most software packages allow this kind of tracking. This enables management to consider a more complete set of possibilities rather than simply querying whether the project is on or off schedule. It also opens the door to more nuanced analysis, such as finding the maximum allowable time for a problematic task if all other tasks are performed at optimal times. In real life, one project schedule often impacts other schedules, and thus CPM software and analysis is also applied to a multiple project environment. In this case, individual steps within projects or the entire outcome of a project can be linked with phases of other projects, providing managers a means through which they can optimize scheduling across projects to maximize efficiency and serve other strategic functions. When integrated with cost tracking, CPM is sometimes known as least cost scheduling. By linking time variations with anticipated costs, the CPM model can be used to calculate the optimal project schedule to minimize the cost. This can indicate, for example, that it is cheaper to take longer at some things but not others. At the very least, it can indicate what the financial consequences will be if the project falls behind schedule at any particular stage. CPM has also been used in conjunction with statistical process control, a set of mathematical methods aimed at monitoring and improving efficiency and quality to maximize these benefits in the course of completing a project. Now, what are the differences between CPM and PERT? Following are the differences between CPM and PERT. There are many techniques for faster and more efficient completion of complex projects. CPM and PERT are two powerful tools to achieve this objective. There are similarities in the two techniques as they serve the same basic purpose. Due to complexity of projects, it is often difficult to eliminate time delays and cost overruns. However, if suitable techniques of planning, controlling and organizing are used, it is possible to reduce these cost overruns and project delays by a considerable margin. Problem with many tools lies in the cost of implementing and executing, which makes them more of a liability than an asset. Such programs, because they require a large amount of reporting and monitoring, far outweigh the benefits that accrue because of their use. These problems are very much done away with when a project manager uses either CPM or PERT. Let us see what these techniques stand for and how they differ. Firstly, PERT. There is high degree of uncertainty pertaining to completion time of certain activities. Particularly in research and development projects, it is difficult to gauge the time the project will take to complete. In such cases, we can take probabilistic approach for each activity and define optimistic time estimate, most likely time estimate and pessimistic time estimate. With expected time for each activity, it is possible to determine the critical path. Thus, PERT is a probabilistic tool that makes use of three estimates for completion of activities and is a tool for planning and control of time for completion of a project. Next is CPM. Now, CPM on the other hand is a deterministic tool taking only a single estimate of time for completion of any activity in a project. It also allows for estimate of costs, thereby being a tool that can control both time as well as costs. PERT was developed by the US Navy for the planning and control of the Polaris missile program, and the emphasis was on completing the program in the shortest possible time. CPM was developed by DuPont, and the emphasis was on the trade-off between the cost of the project and its overall completion time. PERT considers optimistic, likely and pessimistic time, thereby adding an element of probability to the final figure one obtains. CPM takes only a single time for any task, This time typically would be the likely time for the task. PERT is a probabilistic tool using 3 estimates of duration for completion of activities of a project and is basically a tool for planning and control of time, whereas CPM is a deterministic tool with only single estimate of duration. CPM also allows an explicit estimate of costs in addition to time, thereby CPM can control both time as well as cost. PERT is more suitable for R&D related projects where the project is performed for the first time and the estimates of duration are uncertain. CPM is best suited for routine and those projects where time and cost estimates can be accurately calculated. PERT is event oriented. CPM is activity oriented, that is, CPM network is built on the basis of activities. Also, result of carrier's calculation are considered in terms of activities of the project. PERT is used in project management for non-repetitive jobs such as research and development work, where the time and cost estimates tend to be quite uncertain. This technique uses probabilistic time estimates. CPM is used in production management for the jobs of repetitive in nature, where the activity time estimates can be predicted with considerable certainty due to the existence of past experience. Now coming to the summary. Here's a summary of our learning in this session where we have understood the importance of using CPM and the CPM network techniques. Thank you.